So again, like last time, we are going to record the first portion of the meeting, but that includes the slideshow, but not the second part, which is the contest. And we noticed a lot of people dipped after the slideshow was over, which I guess if you're busy, we can't stop you. But we really think that the part of staying after, working together, working with the instructors on the problems is maybe even more important than the slideshow as part of the workshop. And so we really highly recommend you stick around, talk, work on the problems, work through what you're stuck on, and that's how you're actually going to learn. Because at the end of the day, us reading the slideshow to you is hopefully better than you say like reading Geeks for Geeks, but it's not that different. But talking to us one-on-one, talking to peers, that's totally not something that you can get from a website or a YouTube channel. So yeah, just please, if you can, the session is not over when we stop talking and stop recording. You could think of it almost like the session begins when we stop recording and stop talking. All right. Hopefully everyone has had a chance to open up the slides if you want to. Highly recommend, in case I go too fast or something, or you want to click on a link. I'm going to go to the next slide now. So today's agenda, I'm going to go over what we did last time, and then I'm going to talk about input output, and Sartak and I are going to talk about math, mods, and overflow, and that's going to be the first slightly more than an hour. These are estimates, and as you know, programmers tend to go over their time estimates. Hopefully we are not going to go over by a factor of pi, but in any case, this is what we're aiming for. So last time, talked about what competitive programming is. If you missed it, you might have this idea that competitive programming is defined by hackathons. But while that is a competition which involves some programming, I personally think of hackathons much more like business competitions, and competitive programming in the ICPC sense is much more focused on data structures and algorithms rather than, I guess, software engineering, although data structures and algorithms are important to software engineering as well. But you're given tasks that ask you to read in certain input, do something to it that at first sight might seem like it will take forever, but you need to come up with a clever algorithm and or data structure to do it quickly. So who are we? Last time, just kind of breezed through this, but my name is Jacob Zhang. I'm a third year math and computer science double major. I'm the lead of this workshop. And then let's go in order from left to right on the screen. The other people who've been working hard on this will introduce themselves.
Hi, so I'm Rohit. I'm also a third year CS major with a minor in mathematics. I'm also the content lead for Bruin Quest, which is our annual puzzle hunt in collaboration with 2 other committees. So definitely check that out. There's going to be more info on our Facebook page soon. But yeah, Rishi.
Yeah, I'm Rishi. I am another one of the leads for this workshop. I'm a second year computer science major, and like Rohit, I'm also working on Bruin Quest as well.
I'm Tony. I'm a second year computer science and math major. And yeah, I'm also leading this workshop.
And I'm Sarthak. I'm a second year computer science major, and I'm the assistant for this workshop.
Okay, cool. Thank you, everyone. So you probably know this since you're here right now. Time is from Thursdays from 7 to 9 p.m. And we're starting to get into the actual list of topics we're going to do, which in order are math, arrays, sorting, binary search, and dynamic programming. And here is, again, where we think Intro to CP kind of fits in the competitive programming journey. It's a place to start. We'll have more workshops for beginners that are at a bit higher level, but should follow directly from this one. In the winter and spring, we have our own programming competition, Code Sprint LA, which we highly recommend everyone come out to and compete to win some prizes. And once you have that experience under your belt, there are many directions you could go with it. It's up to you, but we hope that you have fun and that it makes your life better. That's why you should be here. So finally, so editor setup. We recommend VS Code. We all use it. If you have some other editor you prefer, that's fine. We recommend using the G++ compiler somehow. If you're on Windows, a good way to do that is by installing the Windows subsystem for Linux, also known as Windows Ubuntu. But if you don't have any of those things on your computer, you can get everything that you need done using Replit, which is a website that gives you many options, many more than these ones, for running code in the cloud. It's really quite fantastic. You can have like a Linux computer for free, pretty much. The downside is it's a little slow, but that shouldn't be an issue when your program is supposed to run under 1 second anyway. So yeah, so hopefully y'all came to the first workshop, but if you didn't, that's fine. We'll be using this platform called Caddis for all of our contests that we do through this workshop, and we want you to create an account at the link open.caddis.com/register. Once you do that, please tell us your username so that if we have a contest, like a mini contest eventually, we'll know who you are. If you've already done these steps, don't do them again. Please don't fill out the form twice. If you haven't, let's see. I feel like I recognize almost all the names in the workshop. So if you don't have a Caddis account and you're making one now, could you please either direct message me or say something in the chat? Because if no one says anything, then I'm just going to keep moving. Okay, I will give a few minutes. I'm going to pause the recording. Okay, so in the course of the last meeting, we established this kind of basic workflow for doing contest problems where you could start from scratch or you could copy an IO template that we provided, excuse me, and run it in Replit. The way you would do that is because contest solutions are full programs that can be run from the command line, take an input through standard input and write an output to standard output. You'll hear me say that over and over. You just run it, type in the test case, and then it should print out its output, and you can see if that's correct or not. And that's how you would do the contest pretty much. So I'm going to start off the discussion of input output with an extension to that workflow. So what are standard input and standard output? They represent like whatever gets typed into the command line and sent to your program, and whatever your program prints out to the command line. But really, they're just files. And this is a super useful abstraction to think this way, because, like, among other things, it lets you hook up programs together. It's called a pipe. You'll learn about it in CS35L and 111. And it means that it's super natural to think of the input that you're giving your program as just being a file like that you might have sitting on your computer's disk. So what you can do is Now this applies mainly to, like, natively, this applies to Linux and Mac systems. But I think with some modification, you can do this on Windows also. Or if you have Windows subsystem for Linux, that's great. Replit is Linux, so this works on Replit. You can create a file, put your sample test case in the file, save the file, and then pass that sample test case to your program using this less than sign. So if we had our test case in testcase.txt, then you can see it here. I wrote a simple program to count the number of integers in the input. And when I run it with nothing, it says there's 0. Now that I've passed this giant file, which apparently has 64 integers, it sees all of that. This is good for a lot of reasons. I think the biggest one is that when you have large inputs, this output could become very unreadable if you're just pasting into the command line, because you'll see output interleaved with your input. And also, it's just a pain to have to copy paste. Like what if you copy something else and then you end up pasting code as your input to your program? I've done that all the time. So I highly recommend this. And I guess like the way to think of it is standard input is a file. When you type into the terminal and hit enter, you edit that file, but you could just like plug in some other file as the standard input. So what does this basic IO template do? Like, here's one that we provided for the problem Kornislav, which was problem D on the last contest, I believe. And there are pretty much 4 main parts. Okay, all this stuff is C++ specific. If you work in Python, you think about almost none of this. If you work in Java, you do think about most of this stuff, but they have different names. We're going to mainly use C++ to teach, and we recommend C++ as the language you use to code. If you have questions about other languages, do ask, though, and maybe we can answer. So we include headers that tell the compiler about the libraries that we want to use. This line, using namespace std, you'll see it all over the place. You might have heard people saying, don't use it, it's bad. In the context of competitive programming, it's great, absolutely use it. The reasons that you wouldn't want to use it are if you were working with some other library system that had names that might conflict with the standard library. But anyway, so when you run a program from the command line, where does it know like where to start? In C++, you indicate this where to start by calling your function main, and its type signature should be int. In modern, like in C++, you can have no arguments. I believe in C, you would have to put in some stuff about argv and argc, but anyway. So you declare int main with no arguments. And notice this is an int function. It doesn't return anything. This is like explicitly allowed. Your int main cannot return anything. And I think the default is just to return 0, which is good. You want to be returning 0. Depending on the contest platform, if you don't return 0, you could get runtime error. Anyway, so declare int main that doesn't return anything, even though it's an int. It says it will return an int. And then there are these 2 pieces that let you read stuff in and out. So there's this cin and there's this cout. And there's these 2 different operators. This one's called extraction. This one's called insertion. Double greater than and double less than signs that you can think of as kind of like, I guess, extracting stuff from cin, pushing stuff onto cout. So yeah, I guess I just said this. We're going to mainly use cin, cout, and there's a helper function called getLine, which can be useful as well. So what headers do you want to include? We typically recommend including this bits/stdc++.h header. Again, this is a competitive programming specific suggestion. We're not saying this is good code form. Don't do this in interviews probably, but This is great for competitive programming because it includes the entire standard library in one go. However, something about this doesn't work on Mac when you're using Xcode. I'm not a Mac user, so I don't know all the details, but the header which contains the cin and cout stuff is called IOStream. So this is the syntax to include IOStream, and if you're using Xcode on a Mac, you may have to do this. You might get an error doing the first one. And basically all of our code is going to assume that you type using namespace std at the top of your code. If you don't do that, then all of your cins and couts are going to have to be std : cin and std : cout. And no one likes that. So cin kind of just works by magic. You put a variable of a certain type on the right of that extraction operator, and then cin will search through the standard input. I guess something that is good to know is that the standard input is like a file with a cursor. So when you read from standard input, that cursor like advances through the file, so that the next time you try to read from it, like using cin, you won't see the same stuff. You'll have moved on. And this is very intuitive. If you just like imagine like how should these things work. But anyway, yeah, good to keep in mind. So what happens here? Cin, like extraction to foo. Foo is an integer, so it will look through the input for an integer and store that, or store, I think, like, I don't know, -1 or 0. If it's not an integer, I actually don't know what the value is, but anyway, and advance the cursor some. And then we'll do the same thing, like, but this time bar is a string, so we'll look for a string piece of input and store that in bar. And how do we know like what makes a piece of the input? This is more of a question for strings than for integers, and it's pretty obvious for integers, but for strings, the input is broken up by white space, which is defined as spaces, tabs, and new lines. So if you had, say, a whole sentence of input, then doing cin to a string will not give you that whole line. It will just give you the first word. All right, so to see if you've been paying attention, we're going to do a little quiz. Second. I guess quiz is probably the wrong word. We just want to check in, see that you're following, see that we're doing a good job at explaining, because if lots of people get this wrong, then that's on us. And I'll go back and try to explain it again. So the poll corresponds to the slide you're looking at now. And this is a real sample input from a real caddis problem. And here's some code which is trying to read it in. Okay, I'm gonna leave this open for another minute, and please do fill out the poll. Again, it's anonymous, and we're not going to like shame you for getting the wrong answer or anything. You do want everyone to fill it out. If you don't fill it out, we'll assume that none of the questions even made sense, and probably go back and spend more time talking about IO. So. Okay. There's still 5 people who haven't submitted anything. Oh, that number's going down. I guess maybe some of those are the co-hosts. No, I don't think so. Cool. All right, that's everyone. That's great. So I'm going to go back, based on looking at these poll results, I'm going to go back to the previous slide and talk about how strings are written again. So I think that might not have been clear. So when we read in strings, we break up the input by white space, but, and I didn't say this, white space is not included in the string that you read in. So I believe, although maybe you could construct a weird case where this happens, I believe if you do cin, like extraction to string, you will never see a white space character or a new line character in the string that you read in. And that's because when you're reading in strings with cin, cin treats that as stuff to be, like, as stuff, and treats all white space as delimiters. In other words, like separating but not being part of the actual interesting content that we want. And yeah, I can see that wasn't clear because a good number of people didn't get that one on the quiz. All the other ones seem pretty good. And yeah, so I think it's very intuitive for integers that like you would never have a new line or a space as part of an integer. Same principle applies with strings too. Okay. If there's any more questions, please ask in the chat. Excuse me. Or unmute if you're brave. We're happy just to have you ask in the chat. And anyway, here are I guess the answers to the quiz. I'm going to end the poll. And again, the idea is you think of cin, like using cin as like advancing the cursor through the input. So we first read an integer, that's 10. Now, when we're going to read in a string, we know there's a new line character at the end of this line, but that doesn't matter. Because cin treats that as a delimiter, we skip past that to the next actual string, which is A. And then there's a space after that. That space is also a delimiter, so it's not part of what we're reading. Right, so someone asked about getLine. So yes, in certain contexts, you might want to use getLine. For example, if you know that your input is broken up by new lines, but might have spaces in it. And that's actually not super common in competitive programming to have, like, say, sentences as input, but it does happen, and this would be the time to use it. However, getLine works a little bit differently from cin to string in that if you have a new line dangling at the end of a line and you haven't advanced the cursor past it, then when you run getLine, getLine will think that, like, looking from where the cursor is to that new line, it's like an empty line. So you'll just get like an empty string. And this happens very often. Like, I don't know. Smallberg talks about it in CS31. He's pretty upset about this issue, and so am I. This happened to me in a contest just like a couple weeks ago. It took me too many minutes to figure out that that was what I did wrong. I thought something was wrong with my code. Well, I guess something was wrong with my code, but it was this. So you can use cin.ignore some number. I think Smallberg likes 1000, but really any number is fine. And backslash n, new line character. You can just treat this as like a magic string that you run before calling getLine if you think that, like, if you had previously used C into integer or C into string, which would actually just like leave that dangling new line. There's a question, what if a string comes before an int in your file, but you C into int first and to string second? That is a very good question. So you'll certainly fail to read in an integer. I want to say you'll end up with some kind of error value for the integer, but that like chunk of the input will get read, and then the string will contain like whatever the number was, but as a string. But I'm not 100% sure. I'm not fully sure. You might want to check that, say on Replit, and I would be interested to hear. But yes, very good question, and I should know, but I don't. What is the 1000 for? Well, the 1000 is partially like a CS31 with Smallberg in joke, but also it's because like the previous line might end in spaces and then a new line, which really sucks. But like there are contexts where like actually lines like you would expect the line to have like a space before the new line. So if you just did cin.ignore one like to new line, then actually one might skip that space. You'll have to look at the definition of this ignore function. Like let's say there are two spaces at the end. Certainly cin.ignore one comma new line character is not actually going to ignore enough characters to pass the new line. So you'll still have this problem. So it's like there's no way there's going to be 1,000 spaces at the end of the previous line. If there's 1,000 spaces at the end of the previous line, like you have bigger problems than this stuff. That's what the 1000 is for. Yeah. So what Noah said in the chat is correct. Yes. Do you have to use the cin.ignore before every time you use getLine or just once? That's a good question, and I encourage everyone to think about this actually. What would happen if you use this before every time you called getLine? Let's say your input was actually just like n sentences, each of which was separated by a new line character. Maybe there was one integer at the beginning which motivated you to put this in your code. So what would happen is, give you all a little bit more time to think about it, but I'll spoil it soon because we have more things to cover. So I believe what would happen is that you would end up reading in every other line, and it would be kind of a disaster because like getLine doesn't leave a trailing new line. It consumes the new line character as well and leaves you off at the next line. So then you would be ignoring, every other line would get ignored. It would be like, read in the line, ignore the line, read in the line, ignore the line. The dangling new line happens when you mix getLine and the other syntax. So here, I won't out the person who's been asking these questions, but I'm going to post the questions in the chat because I think they are very good questions. Just so it's clear what I'm talking about. So this was the first question, and this was the second question. And I think that, yeah, the second question is like an especially good question. And the answer is no, you just use it once when you transition from using the cin syntax, like cin extraction operator syntax to getLine. Yeah. Great questions though. And these seem like pretty trivial things, but I think two perspectives to take on this are one, like you gotta know it to do competitive programming on your own. And once you know it, it'll be fast and not the part of your program that you worry about, and you'll just like type it like. The other thing to consider, I think, is that in the real world, now I don't know that much about the real world, but from my experience, a lot of computer programs like are basically about taking one type of data and transforming it into some other type of data. You know, whether it's like doing data analysis, or it's a server sending stuff to reading files off its disk and sending them to someone over the internet, that sort of thing. It's all about reading data in and writing it out. Without I/O, like you can like math or like lambda calculus like exists as this like perfect computer, but like you can't input and output from it. So it might be there, like all of the problems might be solved, but you can't talk to them without I/O. So I/O is actually like what makes computers interesting. If none of that made sense, like yeah, I guess I wasn't really trying to make that much sense, but I think I/O is definitely worth thinking about, and that's why we're talking about it. Okay, I'm gonna move on. So output. This is easier than input, I'd say. You just use cout. And here, like, the tricky thing is not using the C++ language feature, which is very nice. It just like outputs whatever you send it in sequence pretty much. In Python, like there's the print function, but the print function is different because it outputs a new line automatically. And cout does not output a new line automatically. So using cout is more about remembering like that it's really very low level and basic, and you have to tell it all the things like there should be spaces between different integers. This is a bug that I've run into. And not outputting enough new lines, everything ends up bashed on one line, and the checker program doesn't know what to do with it. So those are the important things to remember with cout. You can feed it pretty much any type in C++. That's not true. You can feed it strings and integers. You can't feed it a vector. Although there's like you can define your own extraction. You can define your own operator, and then you can feed it a vector. But that's more advanced. Just the built-in one will only take strings and integers, and if you give it a Boolean, it'll turn it into an integer and print a 0 or 1. That's basically what it knows how to do. So yeah. And people like to use this endl thing, ENDL. It also prints a new line, but in addition, it does this thing called flush, which like internally, like your standard output like exists as like a buffer in memory, just like a chunk of memory, and like when you write to it, what happens immediately is not that like every other part of the operating system gets like notified that your program output something. Instead, just this memory buffer like gets written to. And that's very fast. If you want to alert the entire like system that you change your output every time you output like an integer or something, and your program is printing 100,000 integers, this is going to take forever. That's why you shouldn't use endl if you don't intentionally want to. There are other ways to not have that inefficiency in C++. And this is a reason why you might see, I heard an anecdote about this on HackerRank recently, that like actually Python was faster than C++ for this program that had a ton of input and output. And it's because like cin and cout can be slow without certain extra steps. I'll talk, those are not in these slides, but I'll talk about them later if anyone's interested. And something that will make it slower is putting endl. So generally don't do that. But there are situations where you want to do that, such as in an interactive problem. That's something we might talk about in a future quarters workshop, but beyond the scope of this one. Okay, so now that you've gotten this half-hour talk on I/O, which I'm sure all of you like were really excited by, we challenge you to code your solutions up from scratch, but recognizing that we don't want you to be mad because I/O was hard or you like were having issues with it. We will still provide I/O templates for everything, and we'll continue to do that throughout the workshop. Those I/O templates can also kind of just serve as like a hint to get you started on the problem. But for this one problem here, speed limit, we encourage you to try like coding up a solution with no IO. So because we want you to actually code this one, I'll give you longer than usual gap in the middle of the workshop, something like 9-ish minutes, or let's say until 7:50. I'm going to pause the recording. Go for it. Contest is here at Intro CP Examples 2, IO template folder. If you must, is at Intro CP Templates 2. And it's problem A in this example contest. Can you post the link in the chat? Yeah. Could someone post the link in the chat? Thanks. I'm going to pause the recording. Oops, it's the wrong pause button.
Okay, so first we can go over the problem itself, and after that we can talk about IO needed to solve this problem. So in this problem, we're given a bunch of time chunks, and Jacob, could you? So we basically want to find the distance traveled in each time chunk. And for each time chunk, we're given a speed s at which the people travel and the end time for that time chunk. And so we know that to find the distance at a specific time chunk, we just need to know the speed and the time traveled in that chunk, and we can multiply them together to get the distance. And so if we look at a specific chunk, we know the speed, it's s, but to find the time, we need to know the end time of the chunk and the start time of the chunk. So the end time is given to us as input to the problem, but the start time is not given. But we actually do know the start time if we notice that the previous chunk's end time is the same as the current chunk's start time. So by keeping track of the previous time chunk's end time, we can utilize that to find the time difference in the current chunk. So if we just look at the overall solution, we can initialize a variable to keep track of the previous chunk's end time, and we can initialize that to 0. And then for each iteration, for each chunk, we can calculate the distance traveled in this iteration by using the distance formula, and then we can update the end time for the next iteration. So in the next slide, we can see how this would look in code along with IO. So first, you would initialize a variable n, which is for the current test case, and you would take that in using cin. And then using a while loop, we can iterate through the test cases. And then in each test case, we initialize 4 variables for speed, time, previous end time, and the total distance traveled. And then using a for loop, we can take in the speed and time for a specific recording, add the distance to total using a distance formula, and then update the previous time to act as the starting time for the next iteration. And this next part is important. We use cout to print out the number of miles in the current test case. And then we use cin to get the number for the next test case. And this is like the number of recordings that would be there in the next test case, or it'd be -1 if there are no more test cases.
Cool. Thank you, Sarthak. And if there are any questions, there's a question, why -1?
Right, so in the problem, right? In the problem description, usually actually, you might not see this. You would probably see like a number of test cases, but in this case, they say that you have to keep solving for test cases until they give you a -1. So in all the sample inputs, for example, you'll see a -1 at the end. Yeah, as Jacob points out.
Yeah, it's all these details are in the input section of the problem. If you were here last time, we went over like the pieces of the problem. The relevant part to look at for IO is input description and output description. Yeah, you also like you need to output this word model. It's a little silly, but like you'll get wrong answer if you don't. So that sort of thing. Like definitely read the input and output sections. Okay, cool. Is the question, when I try it with replit on an input.txt file and then using the feed it in with the lesson sign, it just loops forever and says 0 miles, but on Caddis, it says my solution worked. That's interesting. We will have a breakout room devoted to the problems from the presentation, and I'll probably be in that one, and we can talk about that then. Okay, cool. Gonna move on. Oh, I think my bottom bar is showing me again. How embarrassing. And then move on. So I guess we claimed that that part would take 35 minutes, and it took closer to 45, maybe 50. Anyway, so there's some basic, or maybe not so basic, but basic to competitive programming math that you will need to know for like every competitive programming problem, mods and overflow. So you may have seen this modulus operator before, or not, but I would hope that you have seen a clock before, or at least be familiar with the way that time is kept in the United States and in most of the world, which is that because like days are kind of like repeating events, it makes sense to have like a number system that loops, but like within a day, you know, time is like it's like a continuous quantity that you can measure with a number, like an hour after 1 o'clock is 2, an hour after 2 o'clock is 3. This makes sense. So how do we combine those two things if we want to be able to like count, but also loop around? And that's what the mod operator does. It says, like, when we've reached a certain number, we get to go back to 0. So in this case, like clocks are mod 12. So you count up like 1, 2, 3, 4 up to 11. Actually, clocks, you hit 12 and it's called 12, and then you go 13 is now called 1. But it's pretty much the same idea. In computers, when you take something mod another number, say like mod 12, any multiple of 12 gets turned into a 0. So if you imagine counting up from say like 1 to 27, you would like pass 12 and then you would get reset back down to 0, so like minus 12, and you would pass 12 again when like you're actually passing 24 on your way to 27, minus 12 again, and you'd end up at 3. So 27 mod 12 is 3. In math words, it's the remainder when you divide evenly by the number on the right. So, which I think is usually called the modulus. So, like when you divide evenly by 12, evenly meaning like divide only into integers, then you'll have like, say 15 divided by 12 is just like 1 in this case. That's what the division operator does in C++ also. And then the leftover is 3, so 15 mod 12 is 3. And you don't have to be just mod 12, you can be mod anything. And here is another way to visualize that. So it's really about like breaking numbers into parts of equal size equal to the modulus. So like, what is 16 mod 3? Imagine 16 blocks. We put them into groups of size 3. And then what's left over is 1. And that's because like the first multiple of 15, or sorry, the first multiple of 3, which is less than 16, is 15. 16 minus 15 is 1. So I think mods are usually explained this way, but that kind of leaves out like the way you're seeing here, but that kind of leaves out like why they're important for computer science, which is really that looping around property. So I think both pictures are good to have in your head, of the clock and of breaking these blocks into parts. Are there any questions? Because we're about to go to a problem. Okay, no questions. Cool. So here is your next problem. This is a problem where if you like are super fast, you like immediately see the solution and you want to code it and you want to submit, it's great. But we're not going to give enough time for most people at this workshop to be able to submit. That's okay. Don't feel behind if you can't. But we do want you to think about it and like get as far as you can, because that will help when we're actually explaining it. Oh, I forgot. We have a poll. So I'm going to leave it on this slide, but I'm going to put out that poll as well, just to see how you all are doing with mods and if there's anything we need to go over again. So yeah, like with the last poll, you want everyone to respond. It's not really a quiz, just a way for us to see how we're doing. Oh, also I will, oops, did not intend to do that. I'm going to pause the recording. So doing this problem, there's an additional kind of implementation trick that we have not taught yet. So don't feel bad if you didn't come to it. But the idea is, one way that you can do this problem is you can have a different variable to keep track of whether you've seen each particular remainder modulo 42. Because we're trying to count the number of different remainders rather than the number of different, just total, like say number of different numbers. That'd be a different problem. So you can imagine having a variable for, did I see something that modded to 0 mod 42? Did I see something with a remainder of 1 up to 41? 0 through 41 are the only possible outputs mod 42, because if a number is bigger, 42 or larger, then like when you divide it by 42, you'll get something which is like greater than or equal to 1, and you'll subtract that out. So we don't want to code 42 if statements and have 42 different variables. But we do have a way that can like map small integers to integers. This is an array. So you can use a vector of integers, vector of booleans, because you know that you're only going to be having zeros and ones, but it's really not that necessary in this case. And then what you do is every number that you read in, so like every number n which you read in, you take it mod 42, you look up that index, or just set that index in the array to be equal to 1, and assume that the array started at 0, everything equal to 0. So that every distinct residue that you get, residue, remainder are the same thing. Every distinct remainder, mod 42 that you get, will correspond to a 1 in your array, and all these things that you never saw will still be zeros. So how many 1s did you have in your array? That's just the sum of the array. So you can just output the sum. Yeah. Now, if you knew like some fancy data structures, you could just make a set and then take the numbers mod 42, put them in the set, output the set size. That's fine. That works too. But you didn't need to know that. And like in a way, this solution is a lot cleaner because arrays under the hood are like nothing. I guess vectors under the hood are something, but really like arrays are very simple. And in that other one, you're using a lot more machinery where you like produce this data structure that has like a red-black tree and like many lines of code making it work. So aesthetically, I prefer the solution. Are there any questions? I'm going to send the problem feedback form, which I realized I forgot to last time, and I'll give a minute for people who want to like think more about this problem or submit. Okay, it seems like a couple people do want to hear the explanation again, but we are behind schedule. I want to get to the next problem. So, like I said before, we'll have some breakout rooms in the last, it's looking like it's going to be the last 20 to 25 minutes of today. And that time is important. Please stay here to talk to us and work on the contest. And I will be in a breakout room to address questions. I'll probably just go over the problems from the slideshow. All right. That I think, oh yeah, I said this before. The slide's kind of dense. Just read it on your own, maybe. It says that you can take things mod a number, like before adding or after, you should get the same result. And same with multiplication. So mod kind of like preserves math. From a math perspective, mod's important. Yeah. Okay. So I'm going to actually stop sharing my screen and start that if you could continue from here in the slideshow.
Sure. Okay, is that working?
Yeah, that works. Just the one thing that comes to mind is our faces may be visible in the recording now. Let's see. All right. How did that?
Okay. Is that okay?
Looks good to me. Go ahead.
Okay, so overflow. So overflow is something that you might need to keep in mind later today. But basically, overflow is an issue that happens when you try to store a value that's too big in a in a memory space that's too small. So for example, we try to store this value 2 billion in integer y, and that's okay. But if we try to store y plus y in x, that will cause overflow. because y plus y, which is 4 billion, is more than x can hold. And instead of 4 billion, we'll get a garbage value stored in x. And although this value isn't technically garbage, it like overflows in a way that you know from before. It's not like useful in your program, so you want to avoid overflow. So to address overflow, just make sure you know which integer size you're using and whether it's appropriate for the problem that you're solving. So most of the time, you'll be using signed integers, which is regular integers, and they support values from -2 to the 31 to +2 to the 31 minus 1. But if that's not sufficient, you would most likely use long longs, which support values from -2 to the 63 to +2 to the 63 minus 1. And each of these have their unsigned counterparts, these ones. But you probably won't use them as much, but they're good to know. So keeping that in mind, try to attempt this problem called another candies. And we'll give you a few minutes to solve this, or just think of approaches to solve it. Okay, sorry, the background noise might be my fan. I'm going to mute myself, but feel free to ask questions.
Sarthak has a lot of fans. It's very popular.
Both. Yeah, basically make sure to use only signed or unsigned integers, and mixing them up can be kind of dangerous. But anyways, let's go over the solution to another candies. So actually, before we jump right into the solution, the problem basically asks us about a bunch of children that have a number of candies. And the problem asks if we can equally divide the number of candies amongst the number of children. And we have n children. So basically we want to know if the number of candies is divisible by the number of children. And in other words, we want to know if the number of candies is mod n is equal to 0. So the way we can do this is add up all the candies that all the children have and take the mod of that by n and check if that number is equal to 0. But there are a few caveats to this question that don't make it that simple. First of all, the number of candies that a single child can have can be up to 2 to the 63. And so what that means is that you can't just read it in like a regular integer. You'll have to use long longs. And also, let's say you read in all of the children's candies in long longs and added them up, you would still run into overflow because the number of candies that a single child can have is up to 2 to the 63, but you can have 20,000 children. And in that case, if you multiply 20,000 by 2 to the 63, you would overflow even a long long. So the way to avoid running into overflow is to take the mod at every intermediate step. So whenever you add a new child, you immediately mod and continue. And so what that ensures is that your sum will never be greater than n. And according to the problem statement, n is not that large. In fact, it can be fit into an integer. And that way you can avoid overflow. So that'll be more clear once we look at the code. So what you want to do is read into a vector of long longs. And then when you iterate through the vector, you want to take the mod of the number of candies at each step, and then add that to your remainder from the previous step. And you continue this process through the number of candies. And at the end, you can check whether your total mod n is equal to 0. And if it is, it can be distributed. And if it's not, it can't be. Some tips about mod. A common use case for mod is you can mod a number by 2 to check if it's even or odd. If it's odd, it'll be 1. If it's even, it'll be 0. And one thing to watch out for is that negative numbers in C++ mod to negative numbers. So for example, if we try to take the mod of negative 100 by 7, you'll get negative 2 and not a number between 0 and 6. And hopefully just using these numbers, you can figure out a way to convert this negative value into a non-negative value. Some general contest tips are to use a file to hold your large test cases instead of having to copy paste. And it also makes it easier to edit your test cases. And you can pass that to your program using the redirect operator. And a couple of people in the chat have already talked about this. You can read more about Modulo online. And like the previous problem, you want to watch out for overflow. So what that means is in the problem, you want to pay attention to the variables that are being given to you, and also pay attention to the size of variables as you solve the problem. So for example, in another candies, you want to pay attention to the number of candies you have in a variable. And make sure to come out to our next session where we'll be talking about arrays and solve even more interesting problems. Here's our feedback form, and make sure to fill this out if you liked something about our workshop or if you didn't like something, and we'll try our best to incorporate your feedback into the next workshop so you can reap the benefits of your feedback right away. The URL is right here and linked on the slides as well. So yeah, please do that. And finally, we have the contest for today. So you can click on this link and get started. The officers will be in breakout rooms to help you with the problems in the contest. And also, if you have any questions about other problems that we did during this contest, Jacob will be in the breakout room.